Hi all of you, I'm Dr. M. Kamaksha, open source software evangelist and an enterprise solution architect. In this video I'm going to show you how to perform exploratory factor analysis using a particular software application called SADSA, which stands for Software Application for Data Science and Analytics. In my last video I've shown you how to install that application in a computer. So in this video I'm just going to show you how to do data analysis, especially exploratory factor analysis. So after installing SADSA, if you open, by the way, I said you should install this as an administrator, otherwise there will be kind of errors. It will, I mean, if it is your personal computing, doesn't matter, but if you are using some other computing where you need to, in your office or maybe where there are so many permissions, the application will not be able to download the required data, especially connected to some of the packages of Python. So now this is the application which I have explained to you in my last video, and also shown you how to, I demonstrated rather, how to install this application in a computer, Windows operating system. So these are the menus. I'm not going to talk about it. If you go to the data analysis, there is something exploratory data analysis, exploratory analysis, and in factor analysis you got exploratory factor analysis. So the idea of the exploratory factor analysis is to reduce the number of variables into an explainable or demonstrable factors. So there is a lot of jargon connected to it. I'm not going to into it, but I request the viewers to go back online and read documentation related to exploratory factor analysis. So what we are doing is actually we are trying to identify certain hidden factors. In other analysis we call them as components, dimensions, latent variables, something like etc, etc, etc. So in factor analysis, especially in exploratory factor analysis, there is a factor. So factor means it is just actually an invisible dimension which is composed of or explained by certain observed variables. Okay. So go online and try to read. So I'm going to maybe sample data. Don't know. Yeah, this is too much. So let me open CSV file. Python. I think this is the only file I have. Okay, so this would be a good point for starting. So this is my data set. So I have how many? So these are the variables in my data set. So I have some 3 of the variables which explains a particular qualitative variable called satisfaction, and 3 other variables, they explain attitude, and these 3 variables explain perception, something like that. This is just a survey data set or data set which is obtained from some certain survey, and my assumption is like that. I assume that there are 3 factors in this data set, and expecting these 3 variables, I mean those variables which are named with this 1, 2, 3, they explain satisfaction, a qualitative factor called satisfaction, and A1, A2, A3 explains attitude, P1, P2, P3 explains perception. So now if that is the intention, then go to the factor analysis, exploratory factor analysis. It will ask you enter numeric data variables. So S1, S2, S3, A1, A2, A3, P1, P2, P3. And then if you don't have S1, S2, S3, A1, A2, A3, P1, P2, P3, okay. Now this, it will produce 2 different output windows. One is for the Bartlett chi-square test, and Bartlett p-value, KMO overall partial correlation measure. Now the Bartlett's p-value should be significant, which is not in this case. Should denote significant value of chi-square statistic. So here in this case the p-value is greater than 0.05, So Bartlett test actually speaks about the null hypothesis for this test is that the data subset which I have input into this analysis is actually the correlations in that data set are 0. So alternative hypothesis, they are other than 0. So here, so the p-value, after looking at the p-value, we cannot reject the null hypothesis. So though there are some certain correlations, valid correlations among the variables, but it is highly likely that the real correlations in the population are close to 0, something like that. I'll just show you later. Remember this particular point. I'll perform other analysis and then here it should be greater than 0.5, and KMO measure denotes partial correlations. So the value must be greater than 0.5. These are all actually benchmarks. There is no scientific observations that this should be like this, it should be greater than like that. This is just a commonly accepted. Now when you look at the scree plot, there is no definite pattern in the scree plot, and maybe first two factors can be valid, but the graph doesn't show a valid elbow structure. But even then, two-factor solution can be a good solution for the analysis. Now I close this. I will go to the factor loadings. If you look at the factor loadings, now all satisfaction variables explains the loadings are positive but not strong for factor 1, and attitude also positive but not strong to factor 1, but perception together with one of the variables of attitude are negative. So I may not be able to conclude or draw the inferences. I cannot get into the context without knowing what is S1 stands for, S2 stands for. Maybe S1 is about package, S2 is about pricing. In that context, what happens? The package explains factor 1 positively and the price positively, but comparatively lesser. So this is how factor 1 and factor analysis is done, and the factor loadings can be obtained from this software application. If you are not sure, how to interpret this in a quite meaningful way, straight away go to the ChatGPT and then copy this. These interpret results. Don't know, kind of. So here there is loadings show high strongly, loadings greater than 0.04, meaningful loading close to 0, weak relationship. Now for factor 1, P2 has very strong loading and S3 also has very strong loading. So whatever happens in between these two variables, perception and satisfaction, especially tightly connected to these two variables, going hand in hand. Maybe if the perception P2 speaks about positive attitude and S3 speaks about high level of satisfaction, then the positive attitude yields positive high level of satisfaction, something like that we can. And factor 2 again, three of them, they're all equivocal. This time S2, A2 and P3 go hand in hand. So maybe based on this, what is this P3, what is A2, what is, it all depends on interpretation, always come back to the context. Since I did not speak about context, I am just going in an abstract, generic way. So what happens, P3 also happens in A2 and as well as S2, which means these three variables go hand in hand. So whenever there is a kind of, I cannot say that change affects change in other variable, but so that's it. So it is a two-factor solution. So here what it looks like, S3 and P2 are tightly connected, and P3, A2, S3, S2 are tightly connected with the magnitude and direction of the on the loading. So this is how exploratory factor analysis can be done in this application. Maybe you can just have some certain contextualized data set in your hand and then upload and perform analysis so that you can figure out the relationships and make more meaningful interpretation to this data. So thanks for watching this video. Stay tuned for the new content, and bye bye for now.